Hello and welcome to the training video for OBD or onboard diagnostics. Information plays a huge part in vehicle diagnosis. If you've watched the videos in the diagnosis section, then you'll be aware how to access fault codes and actual values. Understanding that data enables you to make better diagnostic decisions. These days, the majority of mainstream vehicles have to comply with OBD legislation. This means there will be additional diagnostic data available that's emissions based. It's a separate diagnostic program that meets European legislation and has to be provided by all manufacturers. It may sometimes help with the diagnostic process. In this video, I'll guide you through common usage of OBD by taking a look at some engine management data. We won't be covering modes 6 and 8 as these are not required by legislation and are rarely enabled by the manufacturer. Firstly, I'll check to see which OBD systems have been found. From the Diagnostic Hub, choose Global OBD. The ET750 initiates communication and displays the Test Steps menu. From here, choose Systems Found and select Continue. OBD only covers systems and data that can affect vehicle emissions. On this vehicle, it's a single ECU for the engine management. If required, the information can be saved to protocols for later retrieval by using the Save button at the bottom of the display. I'll select Return, which takes you back to the Test Steps menu. Next, I'll take a quick look into Onboard Diagnosis Overview. The data here has been collated from OBD modes 1, 3, 7 and 9. The first item in the list gives you chassis number information. This is also available in mode 9 from the Test Steps menu. Beneath this is the malfunction indicator light status, number of error codes, and a host of information on readiness tests. We'll take a closer look at this as we work our way through the different modes. For now, I'll return to the Test Steps menu. I'm going to take a look at error memory first. The ET750 combines mode 3 for stored codes and mode 7 for pending codes as one list. Choose mode 3 and 7 from the menu, followed by Continue. At the top of the display, you're informed that the mill lamp is off, with a total of 1 DTC or diagnostic trouble code stored. Beneath this is the error code P0013 stored in the engine control module. The code relates to the camshaft timing on bank 1. Below are a list of readiness tests. Those that have been completed are listed as ready. The ones yet to complete indicate not finished. More on this later. There are several function buttons at the bottom of the display. The button to the right will display help instructions for the code where available. Next to that, Clear. It does as its name suggests and clears the error codes. Update will reread any codes, and Save records the information to protocols. Okay, so we have a fault code, but OBD can also give additional information that may help, especially if the fault is intermittent. This is where mode 2 is used. Selecting mode 2 takes you to operating conditions. We're given the code in question, which is P0013, and useful values that were recorded at the moment the error was stored. Using the scroll bar to the right gives access to the whole list. It looks like this particular code was raised at idle whilst the car was warming up. Now I know when the code was raised, I could clear the code and focus my initial test routine within the warm-up phase, possibly shortening diagnostic time. You've seen how to clear error codes from within mode 3 and mode 7, but it's also possible using mode 4. Once the fault memory has been read, selecting mode 4 and moving forward with continue will attempt to clear the fault codes. We can see here that ours have been successfully erased. It's worth remembering that when you have a stubborn code that won't delete in the manufacturer's program, deleting the fault in OBD can often fix this. Once a repair has been carried out, it's good practice to check that it's not going to come back. Part of this process could be carrying out the readiness tests for engine management based faults. Back at the Test Steps menu, select Readiness Tests and proceed with Continue. We're now shown a list of 6 tests. 3 have been completed, showing ready, and 3 yet to complete, listed as not finished. The vehicle will have to be driven on a test cycle until all the tests show ready. The Update button should be pressed periodically to refresh the display. So that's covered error codes and readiness tests, but what about actual data? In some instances, OBD may show data not covered within the system program. One example of this would be lambda values. We'll take a look at this now. Selecting mode 1 and continuing displays actual data. We're going to take a look at oxygen sensor current, bank 1, sensor 1, along with the oxygen sensor value, bank 1, sensor 1. I can now check Show Selected Values Only to limit the list to just that data, and stimulate a change by increasing RPM whilst monitoring the response. We should see the current swinging back and forth across 0, along with the lambda value moving regularly either side of lambda 1. Whilst I can see that's happening, it would be better to graph the values using the time profile. To get a more detailed view, I'll change the graph's range. Having done that, it's now obvious that the sensor is regularly crossing the 0 baseline. This is a great way to analyse broadband sensors. As you've seen, OBD is focused around emission-related data. We'll take a very quick look at Mode 5 next and the kind of information that's available. I'll pick Mode 5 from the Test Steps menu and continue. The data is retrieved and the display populated. The data will now remain on the screen unchanged until Update is selected, which will repopulate the display with new information. Should you require help to interpret the data, generic help is available by selecting the question mark. I'll then locate Mode 5 and choose the blue hyperlink. A lambda sensor waveform is displayed, along with descriptions of the test identifier. Okay, now you have a fundamental overview of OBD. Why not incorporate this within your diagnostic routine? It can be a great help, especially when fixing engine management related faults. Thanks for watching.